Good morning. My name is Joel Alexander Thomas, and today I'm going to show you how I implemented the game physics in the advertisement I chose to present. The advertisement I chose is a thumbs up ad in which the hero jumps off his car out of a plane and falls through gravity and opens the parachute to slow his descent towards the earth. So let's see how I implemented this. Here, instead of the plane, I used a floating runway so that I get enough momentum to have a successful jump for this ad. So let me show you the floating, that's going to be the plane right here. Like this, I have created a plane so that I go through it and get the momentum. So I had two types of physics which needed to be implemented. The first one is the car physics, and the second one is the parachute physics. I have also included a gamer's touch to make it more interesting. Let's firstly look at the car handling and physics. So let's jump to the simple car controller script. And it's going to be this one. So the script, as you can see, has many variables which are prerequisite. I will explain them when they appear in the following codes. So the first method, let's look at the functions right now, methods. The first method is the get input method, and this method basically we take input from the user to move front, back, left or right. The m forward input and the m horizontal input are float variables which gets the extent of the input, the vertical and the horizontal axis respectively. So these are basically the default keys that Unity provides us. You can actually find it in Unity by going ahead and clicking on edit, and if you go to project settings and if you click on input manager, you can see the horizontal and vertical axis and the button corresponding to it. Okay, so let's move ahead. Now the next function is steer. In this function we take in a variable m steer angle and equate it to the product of the max steer angle, which is supposed to be around 30 max steer angle, and the horizontal input, which is the m horizontal input. In the next two lines, we take the wheel collider component of the front wheel. So because the front wheel are the ones that move left or right when we turn, and equate its steer angle to the steer angle we calculated, that is m steer angle. Okay, in the function accelerate, we take we take the wheel collider of all the wheels and add torque to all the wheels so that the wheels move forward together, because there is torque so that the wheels move forward. And in the next function, that is braking, when we press the down arrow key, we get an acceleration backward so that our car stops immediately and not gradually. Okay, that's why we are putting in the force mode dot acceleration. Okay, so in the next method, that is the update wheel position, it is a helper method of the function update wheel post, which we will get to it in around some time. Let's look at the function that is the limit rotation. So in the limit rotation, as the name implies, we are trying to limit the car's rotation so that it doesn't turn on its back all the time. So if the car dot transform dot rotation dot x is something greater than 25 degrees, or we can say 25, it is greater than 25, it will freeze the rotation, car. Okay, so it doesn't turn all the time. So let's go to the update wheel post as I have mentioned above. So basically update wheel position is a method. It takes two parameters, which is a wheel collider and the transform. And wheel collider and transform both are of the wheel. Both are meant for the wheel. So okay, so what this function does is that it updates the position of each wheels moving front and back and also rotating, so that it feels that the wheels are actually driving. That's why we take the wheel update wheel position. So we need to have to apply it to all the wheels. So that is actually the reason why we use this function, so that we can apply it to all the. That's why it is helping the it is a helper function for the update wheel position. Now, lastly, the fixed update, we are just calling all the functions we created, and also we are having a condition, so that we can change the camera angles. Actually, I have implemented two cameras. One is the side camera and the main camera. So when we press the button C, and if the parachute is not open, we can toggle the camera to the side camera and the main camera respectively. So this much are the functions, and now okay, and now we can go to the parachute physics. So let's have a look at the parachute logic script that we can just go through here, and yeah, this is the parachute logic. Okay, so basically there are two methods in this parachute logic physics, which are important. So the first one is the open parachute method, as you can see, in which we are trying to open parachute by setting the parachute game objects. These are the parachute game. There are three parachute game objects. By setting the parachute game objects to true, so they are visible in the game. Now, since the parachutes are open, we have to reduce the descent of the car by increasing the drag on. So we take the game object car, and we take the rigid body component. Inside it, we have a drag, and we make it around 2.2 F, so that it reduces the descent towards the ground. And since we have opened a parachute, we have to zoom out a little bit so that we can see the car as well as the camera. So we have to make the parachute camera game object to be set true, and also we want to make a goal is parachute open also to be true, because it implies that our car is actually having its parachute open. We can use it in script and make further adjustments also. Okay, and the second method is the on ground method, where we take everything just opposite to what we did in the parachute method. Like we make the parachute game object to be set false, so that the parachutes are not visible anymore when we reach the ground. And also we make the drag to be zero, which is the default drag, so that it does not slow the gravity towards the ground. And now let's look at the update method. The update method, we want the parachute to be open when it is not on ground, and when we press the space button, and also there is a timer. There is a timer only after which the parachute should be opened. So when the timer reaches zero only, we can open the parachute. Okay. So also, we want a parachute to disappear when a car is close to the ground. That is, the Y position, the transform Y position of the car should be around less than 175. It's an experimental value that I found out while I was creating it. So I found out that 175 is very close to the ground. So when it reaches 175, parachute will disappear and the drag will be set normal. While the parachute is open, we also want to control a parachute up, down, left, and right, so that the parachute doesn't fly off anywhere it wants. So this whole code is meant for that. Where there's a left arrow, right arrow, up and down arrow, that we can control the parachute, the car on in air with the parachute. So this is the main logic of this game, and now I would like to thank you for patiently listening to me. Again, thank you all.